Hey everyone, welcome back to Code Streak Daily. In today's video, we are going to solve the Leetcode's problem, and it's a hard problem. Okay, so here we have the title Parsing a Boolean expression, and let me read out the description. A Boolean expression is an expression that evaluates to either true or false. It can be in one of the following shapes: T that evaluates to true, F that evaluates to false. There's an expression given that evaluates to the logical not of the inner expression, sub-expression, and we have another expression that evaluates to logical and of the inner expression, sub-expression 1 to n, and we have another expression that evaluates to logical r of the inner expressions of this expression. Okay, given a string expression that represents to a Boolean expression, return the evaluation of that expression. Okay, so this is totally about the bitwise operators. That's it. So here we have an expression, we have an AND operation, there are braces open, we have an OR operation, we have then a brace with a func F. So firstly, we'll evaluate what's inside the brackets only. So here we have firstly we have F. So there is no operation to perform on F. So we'll remove the brackets. We'll perform OR operation on F. So that will be F only. Then again we'll have the uh, let me type that so that you will understand easily. So here we have expression like this. Okay, so firstly we are going to evaluate whatever is inside the first brace. Okay, whatever is inside the first brace, that's it. That means the inside the first brace we have F, that's it. So we are going to perform a operation that is on F. As there is no operation to perform on F, we'll just return F. So that means we'll have and a brace with OR operation and F. Okay, that means we are going to perform the OR operation. OR operation with F will return F. That means we will be left with and F. That's it. So the expression is now and F, and anything that is with something true will always be true, right? So in basically we'll assume that as there is one condition there is one expression that is already true. So we are evaluating F with that expression. Okay. So let's assume F is also true and we have another expression which is also true. True and true will return true. That means we are going to return F. Okay. Where we are going to return F. Here we have what does that F return? F returns to false. So we'll return false. Okay. Now here we have another expression F, F, F and T. Okay. So let's see how that expression works. So here we have OR operation performed on F, F, F and T. Okay. So let's perform the OR operation on all the expressions that is inside the brackets. Okay. So F OR with F or with F or with T. Okay, so when we do an OR operation with false and false, we'll return false. When we do OR operation with false and true, we'll return false. But when we do a false and when we do an false or true operation, it will always return true. So in that case, we are going to return T. That means which will return true. Okay. So now here we have another expression which gives not operation, that is the negation condition, and also F and T. Okay, so firstly we have to analyze what is inside the brace. Okay, so here we are performing AND operation on F and T. Okay, as I said that false and true will return false only. So in this case it will return false. Okay, so this expression is evaluated. Now what will be left inside the bracket? We will be left with not of F. So what is the negation of false? It's true, right? So we are going to return true. So as you see here, not of F, not false, true. We will return true. So this is the basic understanding of how the bitwise operators will be used on certain expressions to solve the expression. Okay, so we are going to do that now. Okay, so now let's jump into the problem solving. We just need the basic understanding of how uh, bitwise operators work. Okay, first here we have the solution class. Inside the class we have the function parse bool expression, where an expression string is passed and we are going to return the boolean value. Okay, so for that we'll use the stake data structure, because stack is used for boolean expressions are often nested, and we need to evaluate the deepest sub expression first, similar to how we process parentheses, right? So we will firstly loop through every character in the expression. As we go, we'll ignore the commas and focus on pushing useful characters into the stack, like logical operators like bitwise and or not, or the boolean values that are given like t and f. Okay, so I'm taking like for char in expression. So if char not equals to close brace and char not equals to what we said, we have to ignore the commas also. Okay, in that case what we are doing, okay, first of all I need to initialize a stack, right? I forgot that. Let me initialize the stack here. I'll take stack equals to an empty list. Okay, as I have initialized the stack, now I have to append it into the stack. What do we have to append? The character, right? Next, this step ensures that we'll collect all the important parts of the Boolean expression into the stack. We'll skip commas because they are just separators between the sub expressions. Okay, next, we have to handle the sub expressions. Now, it is the interesting part. When we encounter a closing parenthesis, it means we have reached the end of a sub expression. Okay, at this point, we'll pop values from the stack until we'll find an opening parenthesis. These popped values represent the true or false values of that sub expression, and we store them in a temporary list. Okay, so elif char is equal to the closing brace. In that condition, I'm initializing the temporary list, and what we have to do, we have to pop the uh, items from the stack until we find another opening brace. Okay, so while stack and stack of -1 is not equal to what? An opening brace. Okay, so I'm taking a variable t equal to stack dot pop. It will store the element that we have popped from the stack. So I'm taking a exp dot append true if t equals to t, else false. So basically we are appending the value into the temporary list exp. We are appending true if the popped value is t, otherwise we are appending false. That's it. Okay, so basically why do we pop the stack? We are essentially backtracking to grab all the boolean values within the current parenthesis. This is why the stack works perfectly in this scenario. As I said, that we have to firstly perform the operations on the inner expressions, right? So that's why we are popping until we find another opening brace. Okay, so we have done that. Next, what we have to do now, we'll also uh, pop the stack, because we have to pop the opening brace from the stack. Okay, we have to check if stack, if there are any other elements. So t equals to stack dot pop. So we'll get the operator before the first opening brace or the any other opening brace, then I am taking another variable v equals to exp of 0. Okay, why we are initializing the result with the first value, then we have to perform corresponding logical operation, right? So if t equals to the AND operation, in that case what we have to do, for b in expression we have to perform the AND operation on b. Okay, if that's not the case, then what we have to do, if t equals to what, OR operation, then in that case what we have to do, for b in exp we have to perform the OR operation on all the values. Okay, if the not these also, if we have the negation operation, then we just need to perform v equals to not v, that's it. So once we have collected all the true or false values from the sub expression, we'll pop the parenthesis, opening parenthesis from the stack. Right before that opening parenthesis, if there is an operator like AND or negation operator, we'll retrieve this operator and apply it to the Boolean values in the exp stack. Okay, so we have done everything. Here's where the logic gets applied. Like if the operator is AND, all the values in the exp must be true for the result to be true. If it's OR, only one value needs to be true, and for not, we just negate the value. That's it. Then we have to push the result back to the stack again, right? So after performing all that, we have to push, right, again stack dot append t if v equals to t, else what we are performing, just the false, right? That's it. Now we have to return the stack. That's it. Now what we are doing, we are just returning the stack of -1 equals to t. We are just returning the value. Okay, so if the result is t, we will return true, otherwise we will return false. Now let's run the code and check. Okay, index error pop from empty list in the line 15, right? Okay, I think if there are empty elements, we are not able to perform the pop operation. Let me check on that. So I checked the code. I think we have put this inside the while loop. We have to put outside, and here the stack dot append should also be inside the if condition only. Okay, so now let's run the code and check. Okay, so our code is accepted. Ooh, we have a runtime of 0 milliseconds. I hope that the same thing as yesterday will happen. Let me submit the code and check. Yeah, see guys, we have a runtime of 11 milliseconds. Yesterday it was 0 milliseconds. Yet our code beats all the 100% of users, and we have done a great job. Okay, so I hope this breakdown helps you understand how to evaluate the Boolean expression using a stack based approach in Python. And if you enjoyed this video, please give it a thumbs up and don't forget to subscribe our channel for daily coding tutorials on Geek for Geeks as well as on Leetcode. See, we have improved a lot and we are getting a consistent 100% user beat on Leetcode. So please do subscribe the channel and hit the bell icon to get the daily updates, and don't forget to like the video. If you have any suggestions or queries, please do put that in the comments. I'll surely check on that. And if you have any code of your approach, please do put that in the comments as well. I'll surely check that. Until then, keep streaking guys.